In this video, we're going to talk about functions. In the last video on relations, we talked about given a relation, how to determine what the domain and range are. Now, given a relation, let's determine whether it is a function or not. So once again, I'm going to start with some type of function mapping, or some type of mapping. So in this group, I'm going to put the numbers 1, 2, and 3. In this set, I'm going to put the numbers 4, 5, and 6. Then I'm going to show a mapping from my domain values to my range values. We said in the last video that these are the x values and that these are the y values. So again, we say that these are the domains and this is the range. So the domain are all the x value, the range are all the y values. And what happens is when I move from the domain to the range, hopefully we have what's called a function. Alright, we pass it through some function and we get an output. Alright, so one way I like to think of this is by looking at it in terms of a person and their birthday. This is just one way that I like to think about it in order to help me determine whether something is a function or not a function. So the person represents all the x values. The birthday represents all the y values. So looking at this, we see that each person has only one birthday, and that's a true statement. So as long as it's a true statement when we're done, we're saying that it is a function. Let's look at a counter example. Let's say I gave you -3, 2, and 8, and over here let's get 7, 1, and 3. In this one, let's say that we have a mapping that goes here, 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 and here. So, again, we still have the person and their birthday, or the x and y values. So if the x values represent the people, let's see how many birthdays each person has. So -3 is saying that they have 2 birthdays, which is 7 and 1. Of course, that is not true. One person cannot have 2 birthdays. So when this is the case, we say this is not a function. Okay, this is not a function. Now, looking at 2 and 8, we also see that they both go to the same y value. This is okay. It's okay for 2 people to have the same birthday. For instance, twins would be an example of that. But the only way someone can have 2 birthdays is if they lied about their birthday, and that's just not possible. Alright, so let's look at a couple of other examples. Let's look at the relation as a set of points. So we'll have 1, 3, 2, 4, 8, 9, and 7, 4. So looking at the relation as a set of points now, what we see is that each of the x values are different. So when the x values in some relation or set of points are different, then that's saying that each different person has a birthday. It is okay for 2 and 7 to have the same birthday as long as they are different people. So each x value has only one y value. So in this case, this is a function. Another example. If I gave you -3, 1, -7, 2, -7, 3, and -4, 8. In this case, we see, looking at the x values, that the 7 appears twice in two different points. So since the 7 appears twice, we look at the y values and notice that the y values are different in each point. When that is the case, we say this is not a function. Okay. So again, using the idea of person and birthday, if no one person can have more than one birthday, or no one x value can belong to more than one y value. Okay, let's look at this graphically now. So if I look at it graphically, I can take the value, a graph that looks like this. In this case, what we're going to do is use what we call the vertical line test. And in the vertical line test, if I draw a vertical line anywhere on the graph, it cannot touch the graph more than once in order for it to be a function. So we notice that this vertical line only touches the graph one time, and therefore anywhere on the x-axis or on the graph, if I draw a vertical line, it's only going to touch the graph one time. Therefore, this is a function. A counter example would be, here I have a coordinate plane, and this time my graph looks like this. All right. Now when I draw a vertical line, that's not what I wanted. Let's draw it thinner here. Now when I draw a vertical line anywhere on my graph, this time one x value gives me two y values. So if it touches the graph more than once anywhere on the graph, that would mean that it is not a function. So it does not pass the vertical line test. So, how about you guys try these two, press pause, and then we'll discuss whether it is a function or not. So let's say our first graph is like this, and our second graph is, this situation. Try these and then by pushing pause. Okay, so what you should have gotten is that the vertical line passes in this case. So anywhere on the graph I can draw a vertical line and it will only touch the graph one time. So this one is a function. On the second one, if I draw a vertical line anywhere on the graph, at this location, it'll cross the graph 3 times, matter of fact. So therefore, this is not a function. Okay? The last thing we're going to discuss is evaluating a function. So in evaluating a function, let's say that you're given a function f of x is equal to x squared minus 3x minus 1. And what we want to do is find two things. We want to find our first example, which will be f of negative 2, and our second example will be f of a, or let's use a plus 1. So for our first example, when we evaluate this, this means that wherever we see an x, we're going to substitute in a 2. So I'm rewriting my equation. To find f of 2, we're going to put in 2 squared minus 3 times 2 minus 1. So in solving this, or evaluating this, we see we get 4 minus 6 minus 1, which ends up giving me, or plus 6, sorry, ends up giving me a 9. Okay? So that says that f of 2 is 9. When I input a 2, the output is 9. Alright, let's look at example 2. In example 2, again, we start off by rewriting the function f of x is equal to x squared minus 3x minus 1. And this time, we're going to substitute in a plus 1. So that's a plus 1 squared minus 3 times a plus 1 minus 1. So the first thing we have to do is square our term by using the FOIL method or box method. So we'll end up getting a squared plus 2a plus 1. Next, we're going to distribute negative 3 into the parentheses. We get negative 3a minus 3, and then minus 1. Now what we want to do is add the like terms. So in adding the like terms, we're going to get an a squared. 2a minus 3a gives us a negative a. And then here we have a positive 1 minus 3 minus 1 will leave us with negative 3. So that's saying that f of a plus 1 is equal to a squared minus a minus 3. Okay? Thank you very much.